Latitude Media, covering the new frontiers of the energy transition.
I'm Shayle Kann, and this is Catalyst. What's your outlook on timelines? Do you think that the lead times just get longer and longer and longer? Are we at the peak there? Is it going to get worse? Do we know?
A good question. I actually don't think they're going to get much worse. I think all of the OEMs are working like crazy to try and shorten up their lead times, or at least make sure they don't get worse.
Coming up, it's due time we talk about the gas turbine market.
Do you want instant access to energy storage supplier pricing that's project-specific? Or the ability to compare domestically made battery and PCS options across the market? ANSA now offers the industry's first battery energy storage data and analytics platform to make better development and procurement decisions. ANSA provides in-depth commercial, technical, and risk data and analytics to help developers choose the best equipment for any project. Improve your returns and save months of evaluation time with ANSA. Learn more about ANSA's energy storage subscriptions at go.ansarenewables.com/latitude or click the link in the show notes.
Imagine a world where connected devices like EVs, home batteries, and smart thermostats work together to support a more efficient and reliable power grid. Well, you don't have to imagine it anymore. This vision is a reality today thanks to Energy Hub. With Energy Hub's Edge DERMS platform, utilities can create virtual power plants through customer-centric flexibility programs, making it easy to manage distributed energy resources and balance the grid. Unlock grid flexibility and reliability through cross-DER management with Energy Hub, the trusted Edge DERMS leader. Visit energyhub.com to learn more.
I'm Shayle Kann. I invest in early stage technologies at Energy Impact Partners. Welcome. So it's a good time to be in the gas turbine business. Between the relaxation of emissions constraints and the rapid load growth that we've discussed innumerable times on this podcast before, perhaps the biggest winners are the companies like Mitsubishi, Siemens, and GE Vernova who make turbines. Of course, one result of that is that they're pretty well sold out and they have a lot of pricing power. So it's an interesting moment where momentum is clearly flowing toward natural gas power generation, but it's also actually pretty difficult to build any more of it, especially in the near term. Anyway, it's a really interesting market and one we haven't really talked about here. So let's fix that. To rectify the situation, I brought on Tony Bruff. Tony is the president of Dora Partners, which is an energy and gas consultancy specializing in what's going on with the gas turbine industry. Here's Tony. Tony, welcome.
Thank you. Glad to be here.
I want to start by you giving me a little bit of a recent history lesson on the gas turbine market. How has it been developing over the past, I don't know, you tell me what the relevant time frame is, but a couple of decades?
Oh, that's a good question. I mean, there's been a lot of dynamic change over the last few decades. It used to be in the 70s and 80s, there were pretty much just two major OEMs, General Electric and even Westinghouse at the time, now owned by Siemens. But really the number of OEMs have gravitated towards three major OEMs, MHI, Mitsubishi Heavy Industries, Siemens, and General Electric, or now it's GE Vernova. There are other strong players in the market. For example, Solar Gas Turbines, a division of Caterpillar, is a significant player in the small gas turbine market. So how's it changed? It's really evolved, not just in terms of the OEMs, but also there's been, several, I'll call them bubble periods. There was a big bubble period in 1999 through 2001, and then the market basically fell off a cliff. And it slowly built back up to a really good set of years back in 2012. And then it kind of fell off again. And now we're kind of at another peak, but I would call today's peak more of a real market-driven, realistic set of scenarios that's driving the market today.
That's interesting that you say that. I mean, because I knew it was characterized historically by these sort of boom and bust cycles. And I think we've seen this in other sectors in the electricity market as well. We've talked before on this podcast about transformers, for example, where you have these very long lead times. And one of the reasons that there are still such long lead times is that transformer manufacturers have gotten burned in the past by building out more capacity and being oversupplied into a market that turned out to bust. And I had a sense that there's kind of a similar dynamic in the turbine world, But it sounds like you're saying this one seems like it's different. What drove those bubbles that then burst in recent history in the market? Was it overexuberance about new gas generation build that just didn't come to fruition, or something else?
No, there's actually several different dynamics, and that's a really good question. If you go back to that first big bubble back in 98 through 2001, that was really being driven by an artificial demand created by Enron. I mean, they clearly were sending artificial signals to the marketplace that were driving up the cost of electricity significantly in several regions of the country, California, Texas, and other areas. And that was also right around the same time that deregulation was coming into play. So those two factors created a lot of panic in the marketplace. And keep in mind, large utilities in the 60s and 70s, everything was regulated. So they were pretty much just, they only built when they could get the public utility regulators to approve investment. But as deregulation came into play, everybody was just basically learning, okay, how do we make money now that there's regulated, deregulated, and semi-regulated markets to deal with across the country, and even to a degree in areas outside the country, in Europe and Asia, for example. So, and then the Enron thing just created a significant, I would say, artificial signal to the marketplace. So those two factors really drove a bubble in the market, and a little bit of it was unreal. I would say at least half of the volume was artificial.
Maybe to put a finer point on that then, because this ties to both the deregulation and Enron, which obviously are tied to each other, but is what was happening there a lot of speculative development of what would be merchant gas projects that never came to fruition? I want to draw that distinction because what's interesting about today's moment is that, like, I don't know, I don't think there is a lot of new merchant gas being developed. Mostly what's happening is it's either utilities saying we need it because we need more capacity, or it's data centers and they'll be the long-term offtake on the project. So you're actually not like subject to the merchant risk. You are subject to the will this data center ever get built risk, which is kind of a different thing.
Well, that's true. But most of that activity was not merchant. There were IPPs. There were a lot of IPPs, independent power producers, that were speculating, without a doubt. But there were a lot of orders that were canceled, even by large regulated and semi-regulated utilities like Southern Electric. They had a huge set of orders, and a lot of that stuff had to get either canceled or bought and then resold on the marketplace. It was a real disaster for everybody when the bubble burst.
So we'll get into the market today in a little bit more detail, but do you think that there is, given that history, given that there is some boom and bust and some cycles that the market has gone through, does that lead to a more conservative approach from, as you said, basically the three big OEMs that control, 70% of the market or something like that, to expand capacity? Or do you think that they share the view that you expressed, which is, actually, this one's real. I'm not too worried about being overextended. If I expand capacity now, I'm sold out through whatever it is, 2029, 2030. And so I should just build as much as I possibly can. Like, where do you think they are on the spectrum?
Yeah. Well, I think there's guarded optimism, very guarded optimism. I mean, certainly all of the OEMs are investing in the future for new production capabilities, particularly Siemens and General Electric, or GE Vernova, I should say. The other thing to keep in mind is about half of the gas turbines that's ordered in the marketplace aren't even for the electric power utility market. They're for the oil and gas market. And so all of the supply chain that's feeding those three OEMs and others are also competing for supply chain resources going into the oil and gas market. And some of those OEMs are also delivering into the oil and gas market. So there's a lot of interesting dynamics going on, and it's important to look beyond just the the power generation or the utility sector when you think about what's happening in the marketplace.
Yeah, can you say more about that? I think that's one thing people don't always appreciate on the outside. What does that supply chain look like, and what are the big categories of sort of end markets that these products get sold into?
Right. Well, that's a great question. I have basically, I describe the supply chain for the gas turbine industry in 4 different levels. I call level 0 is raw materials. So, you talked about transformers. Well, copper is clearly a big raw material when it comes to transformers. But for gas turbines, it's the super alloys, nickel-based alloys, chromium, all those other expensive key ingredients, titanium, all those things that are involved in the raw materials for gas turbines. That's what I call level 0. Level 1 is actually manufacturing the raw pieces of product. For example, blades and vanes and things of that nature that are being cast or forged. Level 2 is where they're actually manufacturing the gas turbine from all those components that were developed on level 1. So that's where the OEMs are producing what I call flange-to-flange gas turbine. And then level 3, which is the 4th level, is where it all gets put together into a final package and delivered to an operator site, installed, commissioned, aftermarket activities, all that sort of thing. So all of those. And then when you keep in mind, levels 0 and level 1 are also being impacted by the aerospace industry. There's something like 40,000 aircraft in backlog right now in the world. Well, guess what? All of the same level 0 material suppliers and all the level 1 forgers and casting shops and things of that nature in what I call level 1, they're all supporting the aerospace industry at the same time. So you can't look in isolation at the electric power utility market for gas turbines in isolation, because you have to consider what's happening in the aerospace industry and what's happening in the power and the oil and gas industry. Because, as I said, 50% of the industrial gas turbines that are delivered in any given year, approximately, aren't even for the electric power utility sector. They're for the oil and gas sector.
And in terms of the market dynamics today, I guess, obviously we have this booming demand for gas turbines in the electric sector, whether on grid or off grid. Some people are doing gas turbines for bridge power for data centers or whatever, but let's call that all in the electric sector ultimately.
Agree.
Is the demand, oil and gas prices are low right now. Does that mean that there's low investment on that side? And so most of the demand is shifting to electric power generation, or is that not sort of how the cycle works on the oil and gas side?
Well, that's a great question, Shayle. The good news is for those that are involved in the oil and gas industry is, by and large, most of the large oil and gas players have long-term thinking in mind. So they're making 5, 10, 7, and 10-year strategy developments for strategy. Now, in any one year they might reduce their order activity because the oil and gas prices are down? Absolutely, that's correct. But in the long run, oil and gas companies basically stick to a strategy, an investment strategy that keeps them investing. And typically what we see are what I call 7-year cycles in the oil and gas industry. It'll go up, peak at about year 7, and then come back down, slowly come back down, and then go back up again on another 7-year cycle. And it's all driven by upstream activity for development of oil and gas, midstream for transmission, and then downstream where you have a lot of LNG, refinery activity, all that sort of stuff. And all those things are somewhat independent of each other. So it does level out the market for the oil and gas industry a little bit, which means that the investment stays. And when you look at the midstream oil and gas market, most of the players midstream, they're making their money not on the price of oil and gas, but on transmission of oil and gas. So they're very much, I don't like to use the word immune, but the sensitivity to the price of oil and gas is really low. They're still going to make money because everybody's still using the oil and gas, albeit maybe at a lower price, but their taxing fee for moving the oil and the gas through the pipelines is still pretty robust, and they're making their money. So they're investing.
Catalyst is brought to you by ANSA. ANSA offers a one-of-a-kind data and analytics platform and advisory services to support better project development and procurement decisions. For energy storage developers, ANSA's platform provides crucial information that you never had easy access to before. Now at your fingertips is real-time pricing for a long list of system configurations to suit any project. ANSA provides a 360-degree view of the market with lifecycle cost analytics and commercial, technical, and risk data. With ANSA, developers can easily determine which products to use in their designs, finance models, and RFPs. Learn more about how ANSA helps save time and maximize profit at go.ansarenewables.com/latitude.
Catalyst is brought to you by Energy Hub. Energy Hub helps utilities build next-generation virtual power plants that unlock reliable flexibility at every level of the grid. The Energy Hub platform takes the guesswork out of balancing energy supply and demand. It uses machine learning to control customer-owned distributed energy resources, like EVs, home batteries, and smart thermostats, to precisely shape load profiles for grid flexibility and reliability. As the industry leader, Energy Hub helps more than 80 utilities manage 1.6 million devices. That's more than any other edge DERMS on the market. Click the link in the show notes to learn more or go to energyhub.com.
I want to talk about, I guess, two primary things with gas turbines in the market, particularly for electricity generation, which is where I spend a lot of time right now. One is timeline and the other is price, right? And so, we hear a lot right now in the news about both of those things. On the timeline side, we hear about folks like GE Vernova being sold out through 2029 with an order book behind that sort of, they can sell as much as they can build, at least at the moment, it seems. And then on price, I don't have visibility into actual market pricing, but one interesting data point that you might have seen recently was, I think it was John Ketchum or somebody from NextEra said, a decade ago, I could have built a new natural gas project for like $750 a kilowatt. I think I'm going to get the numbers close, but not exactly right. And today it would cost me $2,500 a kilowatt. I don't know how much of that is the turbine itself, but I'm interested in the relationship between how long it takes to get new turbines and how expensive they are becoming.
Yeah, good question. That 750 was for a combined cycle plant. And I think the 2,500 is a bit aggressive. But it's definitely up around 30 to 35% over the last 5 years. The price is definitely up. I track all of that very, very closely.
And is it purely a supply-demand thing?
Yes and no. Again, raw materials at level zero, raw materials are up everywhere. Even before all of the tariffs come into place, you were seeing demand on aluminum, nickel-based alloys, titanium. All of these things are all interrelated. Again, I'm coming back to the aerospace industry. When you've got, the aerospace industry, ordering 40,000 aircraft, that's at least 80,000 gas turbines. So, and they're all drinking from the same supply chain. So for the most part. So no, it's not just supply and demand. It's also being driven from, it's of course supply and demand is related to the cost of raw materials. So I don't want to discount that, but certainly raw materials is a big part of it. And if you look at some of the U.S. government's tracking of producer price indices on all of these different elements, you'll see a pretty significant bump in the last 3 years that is very indicative of what you and I are just talking about.
What's your outlook on timelines? Do you think that the lead times just get longer and longer and longer for a while? Where are we in the cycle of the lead times have been getting longer? Are we at the peak there? Is it going to turn back the other direction? Is it going to get worse? Do we know?
A good question. I actually don't think they're going to get much worse. I think all of the OEMs are, in fact, I know all the OEMs are working like crazy to try and shorten up their lead times, or at least make sure they don't get worse. And part of the reason why is that customers are eventually just going to get weary, say, okay, we're just going to put things off because they're, as it is, they're putting down 15, 20, 25% non-refundable deposits. All of those things are very painful for customers. And these OEMs have been living through these things, these busts and booms before, and they don't want to upset their customers too much. So they're all working hard to at least flatten out the timeline and if not improve it. And I'm seeing signs of that across the board.
Today's timelines are lead times are in the like 4 to 5 year range. Do I have that about right?
I would say between 36 and 48 months. I suppose there are some OEMs that are claiming up to 60 months, but I would say on average it's around the 48-month period.
Got it. The other thing I'm curious about is size, right? There's obviously, it's not a monolithic market. Even within power generation, there's different products that serve different use cases and at different scales. And I think the scale question is sort of an interesting one because the question is is what's getting built or what is being designed to get built large scale generation, gigawatt scale type of stuff? Is the fact that data centers driving a lot of this changing the desired scale of the end customer, and what does that mean for the products in the supply chain?
Good question. Well, I actually look at the market drivers. I think there's at least 5 major market drivers. And in each one of those market drivers, small, less than 20 megawatt gas turbines 20 to 100 megawatts are seeing a different set of dynamics. And then what I call jumbo sized units, which are 150, 250 megawatts and above, those I call jumbo units. They're all being affected differently, driven by the different market drivers. And I say there's at least 5 market drivers in the marketplace. One is grid scale battery storage. Number 2, coal plant retirements. Number 3, grid scale renewable energy expansion. Number 4, the rapid development of data centers and artificial intelligence exploitation or expansion. And then just the availability of natural gas and its affordability is, I'd say, the 5th driver. And if you look at each one of those different drivers, those 3 sized units are all being affected differently. And if you want, I could actually walk through each of the different drivers and then explain how each one of those 3 different markets are being affected.
Yeah, it's interesting as you describe that, right? Some of those drivers, I would think, would be a suppressant on demand. So
I agree.
The growth of grid scale energy storage, right? Grid scale energy storage is sort of a gas peaker replacement product on the grid, right? Predominantly. So I would presume that suppresses the market to some degree, but maybe are you saying it results in smaller units being developed on the grid?
Yeah.
Or what's the dynamic at play there?
You're a great lead in, Shayle. Actually, you would think just generically, you think off your head, oh, well, grid scale battery storage, that's got to drive down the demand for gas turbines. Actually, in some cases, the answer is exactly right, but not in all cases. So, if you actually look at the market and what's happened with grid scale, I would say large jumbo-sized units, absolutely, they are it's a negative dynamic. If you look at gas turbines, say 40 to 100 megawatts, actually it's an opportunity because there are several of the developers are counting on gas turbines to recharge or develop what I call hybrid systems that use gas when its cost is low to spin up the gas turbine and recharge their grid scale battery storage. So they're not just relying on renewable energy to recharge their batteries. And then when you look at the real small gas turbines, generally they're not being quite as affected by the grid scale battery storage segment. But clearly, as you correctly pointed out, or you felt intuitively, large power plants, jumbo units, it's a negative. But for gas turbines 40 to 100 megawatts, it's actually a little bit of a positive influence.
And then I imagine, right, coal plant retirements, big projects coming offline, presumably get replaced with big assets, at least if you're trying to do one for one. So I assume it's that is all things equal a positive signal for larger scale turbines.
Yeah, for coal plant retirements, it's really for all three segments: the less than 20 megawatts, the 40 to 100, and the large jumbo. It's a positive influence, but mostly for the large jumbo units. But interestingly enough, you see a lot of mobile power and peaking units being installed as support for the grid where coal plant retirements are occurring.
Well, you see that in the context of some of your other drivers, right? Like I know of some projects that are coal plant is retiring. We're going to replace it with like a big solar plus battery installation. And then we probably need some smaller scale peaking gas to supplement that.
Yeah.
Right. It's like that kind of thing.
Well, yeah. If you look at grid scale renewable energy, I mean, the amount of grid scale activity is going up just explosively. It's expected to double in the next 5 years, and the levelized cost of electricity for solar power is way down. But so that has a negative impact on the large utility or jumbo sized gas turbines, but definitely it has a positive influence on mobile units. Peaking gas turbines, just because when the sun goes down and the wind stops blowing, you've got to have backup power. And those units, I would say, from about 15 megawatts up to 100 megawatts are actually very good investments for, I call it renewable offset.
And when you mentioned the mobile thing, I mean, those types of installations, you're not looking for mobile generators. I think of the mobile generators as being a good fit for either like an off-grid type application. You see a lot of this in the oil and gas world, or for bridge power type situations where you're looking to, this is what you see now where, look, we need power now because we're building a data center and the grid connection is going to take 3 to 5 years. So we need a bridge, but we don't need it forever. Am I wrong to think that that's where the mobile power segment ends up?
Well, you're not wrong, but you're not 100% right either, because clearly when it comes to data centers and artificial intelligence, mobile power and even permanent on-site power is as a backup to and supporting the demand for data centers is a very strong influence on both mobile power and permanent on-site units. But believe it or not, there's a lot of utilities who will buy mobile units. They'll locate them in what they call a grid sensitive area. And over the course of 5 to 10 years, they'll improve their infrastructure. And then they'll move those mobile units to another grid sensitive area. And so the mobile power has just been a fantastic opportunity for basically 3 companies: Solar Gas Turbines, the division of Caterpillar, GE Vernova for their mobile units, and for MHI Aero Power for their mobile units. Those 3 players have done extremely well with mobile powered units for a variety of reasons, even in oil and gas, but for the reasons that you and I have just discussed in the last 10 minutes. Absolutely. And I don't see that market going away at all.
Yeah, if anything, it's getting supercharged by additional use cases, as we've discussed.
Absolutely.
Which gets to that sort of...
You're 100% on target.
Yeah, which gets to that sort of... The one that seems to be the biggest net new thing that's happening right now, but like is a huge deal, is all the gas turbines being developed for data centers, whether mobile or stationary, right? But you see there's that partnership between Chevron and Engine Number One, where they've secured gigawatts worth of GE Vernova turbines. They're going to go use those to develop a bunch of data centers. And then I'm not sure whether those are actually intended to be permanent or just bridge power, but that's one example amongst many. And it seems to me is the factor that's kind of tipping this market over the edge from just being a generally tight market to like a historically tight market.
Yeah, well, you're making a good point. I mean, if you look at data centers, there's like 11,000 data centers serving the digital commerce and artificial intelligence community already around the world. And because many of them have been around, the average electrical load's around 4 megawatts. But there's like 1,400 new data centers planned in the United States alone. And over 1,000 of those are all large scale. They're going to need a lot more than 4 megawatts. I mean, some of those data centers, their electrical load is more than the community around them.
Yeah, there's
I mean, it's just incredible.
Like a electric co-op. I think it's Susquehanna co-op or something like that in Virginia. That I remember seeing some regulatory filing where they were projecting their load growth to like more than double, based on purely a couple of data centers that are coming into the territory.
Yeah, in fact, you just touched on a good point. That whole region around Virginia, Washington D.C., that whole area. There's more data centers in that area than anywhere else in the world.
Right.
It's just a mecca of data centers. But these dynamics are really interesting around data centers, and I don't think it's going away. I think it's you see people using artificial intelligence more. Digital commerce is just booming, and it's not going away.
To me, two things can be true at the same time. I think it can be true that this is the demand from the gas turbine OEM perspective. The demand is real. The market will buy an enormous volume of new gas turbines to serve these markets. And that's also true, by the way, of like utilities who are trying to manage interconnection requests and so on. Like, it can be true that that is real. And also that we are in a speculative bubble on the development side, because there will not be, I mean, as you correctly said, there are 1,000 large-scale data centers in development in the United States. And I will state categorically, I don't think there will be 1,000 new hyperscale data centers in the United States anytime soon. I don't think there's actually that much demand for it. So like, both things are true. There are cowboys out there trying to take advantage of the moment. So the challenge, of course, then, if you are on the supply side, whether it's a utility or you're a gas turbine OEM, is how do I make sure that the buyers I'm signing up with are real? And that gets to your point of like these big non-refundable deposits. If you have all the market power, that's sort of how you take advantage of it. So it seems like they're doing the right thing in that regard, at least.
Yeah. Well, and the other dynamic to keep in mind, Shayle, not only that is, it's not just one of these market drivers that's making things happen. It's all 5 of these market drivers that I've mentioned, including the price of natural gas, which is very affordable in the United States. So when you combine all of these what I call market drivers, it creates a situation where these OEMs are relatively comfortable building out a supply chain strategy to support the market, because they're not just relying on one dynamic. Back when I was, executive at one of these large OEMs, 20 years ago, we were basically counting on only one of those market drivers to happen, and one of them didn't happen. And so it hurt our strategy. But now you have a situation where you have, 3 to 5 key market drivers that are all pinging the market. And it creates a little bit of, I would call, risk comfort for the OEMs, because they know it's not just one thing they're counting on to make the market move.
Okay, final question for you, I guess, is on the technology side. Is there any these are pretty mature technologies. Is there any significant innovation that either we have seen recently or that you expect to see in the next few years? Like, will the market change as a result of technological innovation, or is this just a, rinse and repeat and stamp them out as much as we can kind of a situation?
Yeah, good question. I would touch on 2 areas. First off, all of the OEMs have spent an enormous amount of money trying to get, and they've been very successful in slowly increasing the efficiency of their combined cycle plants. I mean, it used to be combined cycle plants, average efficiency was about 55%. And they slowly crept it up to 60. And then they kind of hit a dead spot, and they couldn't figure out how to get above 60. And then they started developing their, I'll call it, a very holistic strategy to the power plant. So it wasn't just the gas turbine, it was the HRSG, it was a whole, all sorts of different technical factors that they were levers that they were pulling to try and squeeze more efficiency out of their power plants. And they crept it up to 60. Then they got to 60 and a half, 61, 60.3. I mean, they're starting to push 62% efficiency and more. And I don't think they're going to quit, because if you look at the levelized cost of electricity and that's a big factor that these utilities are using in assessing which OEM they're going to use. Fuel is a big element in the levelized cost of electricity. So the more efficient and the more effective that the OEM is in convincing that customer that they have a more efficient unit and even guaranteeing it, the better for them. They'll be more competitive. So efficiency it's not coming up by leaps and bounds, but it's a gradual increase over time that's been quite remarkable, to be honest with you. You got to hand it to all three of the major OEMs that they've been able to make some very significant improvements in efficiency, albeit very difficult. The second big area of technology development is converting their combustion systems over to using hydrogen. Now, I put all of that into a big set of quotes, because while they're all working on hydrogen and they've all demonstrated to a degree some capability of operating on hydrogen, the biggest problem is, where are they going to get it? The amount of hydrogen that you need to run one of these large jumbo-sized units, it's just an enormous amount of gas. And where are you going to get it from? So while they're all spending a lot of money and their engineers are working very diligently and doing some fantastic development, I have some doubts as to whether the market will actually see a significant increase in purchases of gas turbines that actually are using hydrogen. But clearly they're all working on it.
Yeah, it's a the bet is if we build it, they will come. If we build hydrogen-ready gas turbines, then the market will show up for them and the hydrogen will be there. And of course, it's a dynamic market for hydrogen at the moment. So we'll find out whether that plays out well for them. But good point on efficiency. It's like a steady grind, but it adds up a lot over time.
Yeah.
Tony, this was awesome. Really appreciate the time. Thanks so much for joining.
Thank you.
Tony Brough is the president of Dora Partners, an energy and gas consultancy. This show is a production of Latitude Media. You can head over to latitudemedia.com for links to today's topics. Latitude is supported by Prelude Ventures. Prelude backs visionaries accelerating climate innovation that will reshape the global economy for the betterment of people and planet. Learn more at preludeventures.com. This episode was produced by Daniel Woldorff. Mixing and theme song by Sean Marquand. Stephen Lacey is our executive editor. I'm Shayle Kann, and this is Catalyst.